Hello everyone, and welcome to Rough Science. My name is William Say, and today I'll be making lemon soda. Now, I'm not just going to be making orange soda. This is rough science, so the process will be rough and difficult. I'm only allowed to use a certain amount of things. Let me introduce you to the things I'm allowed to use. First, an orange. 1 orange. 2, a transparent drinking glass. 3, water. This water quantity is 500 milliliters from Deer Park, so it's 100% natural spring water. Next, a certain quantity of sugar, baking soda, and a spoon. The first thing that comes to my mind is I'm making orange soda, so I have to start with an orange. Because this is rough science, I'm not able to use a knife or some kind of tool that allows me to peel it, so I will peel this by hand. I have it semi-peeled, and I will now squeeze some of the orange juice into this transparent drinking glass. So there we have it. I have the outside of an orange over here, and I have the inside and some juice inside this transparent drinking glass. So I'm assuming there's no napkins here, so I'm not able to just wipe the thing off my hands. So now I will pour water into this drinking glass. So it isn't all the water, but it's most of the water. Now, making orange soda, I feel like isn't just with the orange inside. You actually have to mix it up. So what I will do now is with the spoon, I'm allowed to use. I will now mix it up and make it so that the solution is homogeneous. Right now it is heterogeneous, as there are, I guess you can say there's pulp inside of the solution. But having a solution be homogeneous is having a solution that is the solute is equally distributed around the solvent. Now, it's obviously gonna be impossible to have it completely homogeneous, but I am going to try the best as I can. Yes, so I feel like I mixed it enough. I realize it's impossible to have it completely dissolved with just a spoon. I will take some of this out. I'll actually eat it. And now I think the next step is to make it sweet. So here we have sugar, and I'm not allowed to use any other spoon or measuring device. And then I'll mix the orange and water. Doesn't taste very sweet, so I'll add more sugar. I guess I want to add a bit more water, just to dilute it more. So over here we see that there are a bit of salt on the bottom of the solution. And what that means is that this solution is unsaturated. In real life, it's very hard to make a solution completely saturated without any device or any like a graph where it shows certain how much solute can actually be saturated, how much solute can make a solution saturated. So if I were to do this with other devices, I would use you can heat it up or change the temperature in order to make some salt actually dissolve. So because we don't have that, we just have an unsaturated solution here. Next up, we have baking soda here. Baking soda also goes by the formula of sodium bicarbonate, which is NaHCO3, and sodium is a group 1 element and is very reactive. Carbonates or hydrogen carbonates, they're usually, I know that carbonates are pretty basic, so I would assume that carbonate has a pH higher than 7. Contrasting with this right here, which is oranges. Oranges are citrus fruits. Like lemons, they have a pH below 7, so they are quite acidic. And oranges I think have a pH maybe 2, maybe 2 might be too much, maybe like 3. And mixing baking soda with with water, I guess it kind of neutralizes the acidity in a way, as water does contain some hydroxide ions. And so I would think this pH isn't that acidic, like 2, 3, but it's definitely not around the pH of water, which is 7. So I would think it's somewhere in between. And adding baking soda, a basic compound, could cause a reaction. Another thing I noticed is that there is the word carbonate at the end of baking soda, and as I learned from chemistry class, carbonates in a reaction does produce water and carbon dioxide. Now, mixing baking soda with some sort of, I guess you can say, acid, as the pH is less than 7, could make carbon dioxide in water. So that's what I think when I add baking soda to this solution here. Some sort of bubbling will occur because of the carbon dioxide. Again, I don't have some sort of measuring device that I can use for the sugar, for example. So I have a spoon here, but I already mixed it with orange water, and I don't really want to use my hands. So I guess the best way is to pour baking soda into the solution and see what happens. Again, I am predicting that there will be some sort of bubbling, and that bubbles will be from carbon dioxide itself. So I'm very surprised that there was a bit of bubbling at the top, but other than that, there wasn't any bubbling, which is kind of weird because I did think there would be some sort of carbon dioxide gas bubbles that would form at the top. I thought there would be more, but one thing I can think of that is that I might have added too much water, and that might have disturbed the pH of this solution. And also, these oranges are pretty small, and I'm only allowed to use one. So I guess there wasn't as strong of an acid that can help, that can react with the base. This is one of the worst things I've ever tasted in my entire life.